In this video, we'll be talking about preference reversals, one of the key phenomena used as evidence for the idea that preferences are constructed on the fly rather than retrieved from a big list stored in our heads. Remember that preference reversals simply mean that we say we prefer one option when the choice is made one way, but a different option when the choice is made a different way. If you said you liked apples better than oranges, but then you said you liked oranges better than apples, that would be a preference reversal. In this video, we're going to talk about two reasons why preferences can reverse. First, the scale on which we make a choice can influence which attributes we pay attention to. So, preferences can differ when we're choosing between two things versus when we're putting prices on different things or evaluating how much we like different things. That's called compatibility. Second, some attributes are easier to understand and evaluate than others, so information that contextualizes an attribute can change our preferences. That's called evaluability. Let's look at some examples. Suppose you had a choice of two different raffles. Raffle A has a 2/3 chance of winning $30 and a 1/3 chance of losing $15. Raffle B has a 1/3 chance of winning $95 and a 2/3 chance of losing $25. Now, I want you to think about what the maximum price would be that you'd be willing to pay for each of these two raffles. So the maximum price you'd be willing to pay for Raffle A and the maximum price you'd be willing to pay for Raffle B. Give it a minute, pause the video, place dollar amounts in the two raffles. Okay, which one's higher? Well, if you're like most people, you put a higher dollar value on Raffle B. Why? Well, pretty simple. It's because the upside payoff of $95 is higher on Raffle B, and when you're pricing a bet in dollars, you pay attention to the number of dollars. But here's the twist. Now imagine I'm offering you to choose between one of these two raffles to keep. Which one do you pick? Think about this for a second. Well, you probably guessed what's coming. Most people pick Raffle A. Why? Because probability turns out to be the single most important piece of information for most people when they're evaluating bets, so they pay more attention to that attribute. As a historical aside, these results were very difficult to believe for economists back in the 1970s. They considered all sorts of possible explanations, like poor motivation, lack of incentives. They even thought that maybe the respondents were suspicious of psychologists because they sometimes used deception in their experiments. But, after a number of very careful experiments by both psychologists and economists, including one experiment in which gamblers in a casino were given these kinds of bets with real money, economists have come to recognize that this is an unassailable empirical result. Preference reversals are real. Let's look at another example of how response mode can alter preferences. I'm recording this during the coronavirus lockdown of 2020, so we're hearing all about how to manage trade-offs between the economic costs of different policy responses, which differ by trillions of dollars, versus the likely effects on death rates from the virus, which are also quite substantial. These are hard trade-offs to make, and many people insist that we must prioritize lives at all costs. So they're effectively saying that a single human life is infinitely valuable. But the following example shows that people can and do put prices on human lives, at least depending on how the question is asked. Suppose you live in a city where two policies are being considered. Policy A will cost $100 million to the citizens of the city, and is expected to save all lives except 20. Let's suppose that someone else proposes an alternative, Policy B, which would save one additional life. But we're not sure how much that policy would cost. What's the most expensive that plan could be such that you would consider it more attractive than Policy A? Think about how you would answer this question and hit pause if you need a little bit of time to think about this. People are perfectly able to answer questions like this. Economists estimate that most people value their own lives at somewhere between $1 million and $10 million. Let's suppose we're being exceptionally generous and we said that we'd be willing to pay another $20 million for Policy B, so we'd be willing to accept a maximum cost of Policy B of $120 million. So the extra $20 million is saving the life of one additional person. Well, that implies that if the true cost of Policy B turned out to be $130 million, we should reject it and pick Policy A. In terms of valuing these two policies, we've decided that Policy A is more valuable because the value of that additional life saved is only $20 million, but Policy B would cost an additional $30 million. But you probably guessed what's coming. Now suppose we know that Policy B costs $130 million and you have to choose which policy to adopt. What do you pick? Many people under these circumstances will change their minds and pick policy B. Why? Because when we make choices, we place a lot of weight on the single most important attribute, which in this case is lives saved, and we pay less attention to less important attributes like cost, even if there's a very large difference on that other attribute. To summarize the principle behind these examples, what we have here is an influence of compatibility, meaning the match between how you're being asked to make a choice and what attributes are being considered. In the case of the raffle example, one was better off on monetary payoff and the other was better on probability. When you're valuing the bets in terms of money, you pay more attention to money because it's similar to the response scale, which is also in terms of money. But when you're making a choice, you pay more attention to the probability since that's the most important attribute for most people. The second example about pandemic policies is an even clearer example of what's called the prominence effect. Some attributes are more important than others. When you're evaluating a computer, the most important attribute might be the ease of use. When you're evaluating a job offer, the most important attribute might be salary. And when you're evaluating a convenience store, the most important attribute might be location. When we're choosing between two options, we tend to pay more attention to that most prominent or most important attribute and downplay all the other things that might vary. So, when I ask you to choose between the two pandemic policies, you might focus on the number of lives saved, which is the single most important attribute. But when we're evaluating an option, for example, rating how much we like it or pricing how much we'd be willing to pay for it, we're better able to make trade-offs among different attributes because this kind of task inherently requires quantitative thinking. I'm asking you to put a number on it. Thus, decision makers place some weight even on less important attributes when they're making more quantitative judgments like willingness to pay rather than binary choices. All right, new principle, new example. Suppose you're thinking of getting a new TV. This TV has a 32-inch 4K LCD screen. Its THD is 0.010%, with higher numbers reflecting higher sound quality, and the model's from the year 2018. How much do you like this TV, and what's the highest price you'd be willing to pay? Do you have a number in your mind? This is called single evaluation mode, and this is where we're just considering one option at a time. Now here's another option for you to consider. This one has a 32-inch 4K LCD screen, a 0.003% THD, which again is a measure of sound quality, and this model is from 2020. How much do you like this TV, and how much would you be willing to pay for it? If you're like most people, you gave a higher number for this second option. You saw that this TV is cutting edge from 2020, and that carried a lot of weight, whereas the THD rating didn't carry much weight at all. But what happens if I ask you to choose between these two options, placed side by side in what's called joint evaluation mode? Which one would you choose, keeping in mind that THD is a measure of sound quality and higher numbers mean higher quality? Well, now most people would choose the first one. Why does this happen? The explanation here is a little different from our earlier examples about compatibility. Here, the difference has to do with how easy these attributes are to evaluate. Evaluability refers to how readily you can judge how desirable an attribute's value is. The basic principle here says that people are more sensitive to an attribute's value when it's easier to evaluate. So why do we choose differently when evaluating the options one at a time versus side by side? It's because sound quality is really quite important to our TV experience, but it's hard to understand the THD scale without more context. When each option is presented one at a time, you basically have no idea whether 0.010% is a good value on this or not. But when I put them side by side, you can tell that 0.010 is much higher than 0.003. On the opposite side, model year isn't really all that important to most consumers, but it's much easier to evaluate model year in isolation, so when you're looking at the options one at a time, you rely more on that attribute. What makes an attribute more easily evaluable and thus makes us more sensitive to its value? Three main factors. First, it's easy to evaluate an attribute when you have some context or reference points, like a range of possible values or a benchmark. If I told you that THD can range from 0.001 to 0.015, you'd be much more responsive to it than if I didn't give you that information. This is the same reason why putting the information in joint evaluation mode makes attributes easier to evaluate. You can compare the two options, so they automatically give you reference points and context. Second, we're more responsive to information when we know a lot about that attribute. This could be because of special expertise. A TV repair person would be more likely to know what THD means and would therefore be very responsive to that attribute, even in single evaluation mode. Or, we might know a lot about an attribute because it's categorical or black and white, rather than a continuous shade of gray. If we're evaluating apartments, for example, square footage is a continuous variable, a shade of gray, that's hard to evaluate without some reference points. But whether or not an apartment has a balcony is a categorical black and white variable that we can easily understand in isolation. Finally, some attributes lend themselves naturally to evaluation. If you can physically see the TV's picture quality, you can judge with your own eyes whether you think it's good or bad. And you'd be pretty sensitive to this even if you're evaluating TVs one at a time. Similarly, temperature is easy to evaluate because you can just tell whether or not you're comfortable. If you felt the back of the TV and it was extremely hot versus room temperature, that doesn't leave much room for interpretation. You'd be very sensitive to that attribute without needing much context. Here's a philosophical question to end our video on. When we shift our preferences based on how our preferences are measured, which option do we really prefer? In a sense, there's really no answer to this question. Our preferences are often constructed on the fly. It's not that there's a big list of preferences in your head that gets distorted sometimes, but rather, the preferences don't live in your head at all. They're the result of the interaction between your mind and the situation you're in. But, now that we understand more about what causes these preference reversals, it's reasonable to ask which response is less biased, since we know that some of these response modes bring out our mental shortcomings more than others. For compatibility-based reversals, it's usually safe to say that responses are less biased in quantitative tasks like pricing or evaluation, rather than choice. Economists insist that life poses trade-offs and we can't have everything. It's a mistake to focus on only the single most prominent dimension and ignore everything else. Thus, unpleasant as it is, it's important to be able to do our best to place reasonable values on even sacred things like human lives, since we often have to make real choices about policies. The value of a human life is high, but it's not infinite. For example, you wouldn't choose to make 1 million people blind to save just one life. Response modes that allow us to bring out these trade-offs are usually going to be less biased than those that don't. And when we're thinking about valuability-based reversals, these are based on the difficulty in understanding or valuing some of the attributes. Factors like reference points and knowledge help us to evaluate subtle attributes, so it usually makes more sense to say that our responses are less biased in joint evaluation mode, where we can compare options to one another. In sum, we can say that our preferences are, to a large extent, constructed, but if we know how they're constructed, we can evaluate that construction process and try to privilege choices that make the most sense on reflection.